SEDA chain, it comes available to what is called the DR tally function. So the DR tally function stands for data request tally, and basically this is just an aggregation filtration system. So in the Oracle program, as we discussed, there is the ability to add in your custom parameters, which could be absolutely anything depending on the use case that you're trying to build. But the kind of TLDR on the DR tally function is that it filters and aggregates whether it's like you want the 10 average 10 sources of New York City real estate data, and you want to get the median value for that one piece of real estate, and that's the most accurate form of data, then it will take all the results from the overlay nodes and it will tally them up to give you the median result. So basically what it's doing is it's following your how should the data be returned instructions, and then it goes via the DR tally function back to the SEDA chain, where it's then put into its data batch. Once it's in the data batch, it goes into a block. Once it's in the block, that is, once it's in the batch, it's signed off by the decentralized validator set here, made available to the solver. The solver then relays it back to the network via the proof of contract. So this is essentially how the SEDA network operates. And to just do a full circle to where we started, your traditional oracles have to redeploy their infrastructure. So you can see that there's a lot of infrastructure here that would be building. Imagine having to redeploy that, retest it, rerun it, change the languages, run audits. The cost, the time alone is the reason why legacy oracles have to charge so much money and take so much time, whether it's 3 to 9 months or beyond. For integrations, and why new networks have to either pay through the nose or they have to provide proof of traction, which is very difficult because you can't really have applications building if you don't have the data feeds that you need. So it becomes this like chicken and egg problem, or they have to use like really low quality data. It's unsafe, it's not secure. And basically we mitigate all that, and we created a development friendly environment because basically they can have the proof of contract deploy it themselves even. To their network in any language. They connect that up to a decentralized solver network, and then once they have that, they can start building their own Oracle programs. They can take from as quick as 97 seconds for a basic price feed, or they could be 30 minutes for some like complex RWA feeds. They could be half a day, depending on how complex and how big you're building it. The point is, they're minutes, not months. It doesn't take months to deploy these things. So once you have your Oracle program on there, you can basically start sending those data requests through for the feeds that you need. And as we always say, the TLDR, the big takeaway here is that people can actually just build the application that they want to build, knowing that the Oracle feed, the data feed that supplies life to their application is achievable because they can just build it themselves in minutes, not months, on the SEDA network. And we are going live to V1 mainnet 3 or 4 weeks from now. Very exciting times because that marks the start of a completely new primitive for oracles, and it starts the wave of innovation, limitless application development.